Flat earthers always try to do experiments. And when they do, they just prove the earth is not flat. Today we have another flat earther to add to that list, and that's David Weiss from DITRH. Hi everyone, welcome back to the channel. I'm Heinrich, the real nuclear physicist. Today we'll be taking a look as David Weiss tries to do an experiment but fails completely.
Okay, the question is asked, how can a 3-foot wave block a giant ship from a 6-foot tall man?
That is a great question, David. And the simple answer is, it won't. On a flat Earth, if the viewer and an object are both larger than the obstruction will never be able to hide the object from the viewer. If the object, however, is far enough away, it might still seem to disappear, even though it's not behind the obstruction. But that would just be due to the resolution capabilities of the eye.
So here I have a bunch of pencils on the floor.
Great! You're actually going to do an experiment. Let's hope everything's to scale and that you don't make a blunder like Bob and Jeranism.
They're going all the way across the room. You'll see them a little better as they go down. And you see the space between them is equal. But as they go down, the spaces get compressed.
The distances between those pencils do appear to decrease. But that's due to something called perspective. And I thought flerfs were supposed to be the experts when it comes to perspective.
As we go all the way down, we see basically from here to the bottom of the screen is about the same as all of the other 30 spaces, however many there are, right? They're all getting compressed. Now, if I got another pencil and put it on top of, let's say, the 5th pencil from the end, it would block all of the other pencils.
And you do realize that even though the pencils appear closer to each other, you can still see the individual pencils. You can still see the furthest pencil from you. Now, if you had another larger pencil right at the front, then you wouldn't be able to see the back pencils. But that's because the obstruction would be larger than the object.
Here we have a 6-foot tall guy. We have a 3-foot wave, and this is his line of sight over the wave to where he can see the water. And there's a small gap in between the wave and where he can see the water. Now, we live on a flat Earth. A 6-foot tall man looking down at the water is looking down 6 feet. If he looks down at the water here, he's looking down 6 feet. Out here, it's still 6 feet below his eyes.
The height from the viewer's eyes would be 6 feet perpendicular to the surface of the Earth. But as the obstruction gets further away, you are no longer looking perpendicularly down towards the Earth. You are looking at an angle. And if you do basic trigonometry, that angle, the further away the obstruction gets, would get smaller. As the angle gets smaller, your hypotenuse of that right angle triangle would increase. And due to a human's eye, the further away an object becomes, the more difficult it is to see it.
But the angle changes. So let's watch what happens. We move that wave out and look at the gap between where he can see the water and where the wave is. It gets longer and longer. Look how wide it is now. And it's really wide.
The gap behind the obstruction gets longer, yes, but it will never get that large that it can obstruct something that's larger than the obstruction itself, no matter how far away it gets. If that obstruction is infinitely far away and your view is basically parallel to the obstruction's height, you will still never be able to obscure more than 3 feet.
So we got our boat right here, we got our guy right here, we got our wave. He's blocking the bottom of the boat, but he could kind of look over the wave a little bit. And if we put the ship out here, he can still see the whole ship down to the water line. Farther out, he can still see it, he can still see it, he can still see it.
Why did that ship go from like 12 feet tall to almost a foot? I do understand you're trying to simulate that it's far away, but you also need to shrink the viewer proportionally as much as you have shrunk the ship and the obstruction. That's how scale works. And like I said in the beginning, everything should be to scale.
Makes perfect sense.
David, you are wrong. There's no other way to put this. Like all flerfs trying to do an experiment, you have failed to prove what you think you are proving. Like I said, you can solve this with basic logic. If we increase the distance between the viewer and the obstruction to 1,000,000 miles to infinity, because if the Earth is flat, there shouldn't be a curve that would get in our way. So we can increase it to infinity. Now the viewer's eyesight might as well be parallel to the Earth's surface. If the eyesight is parallel, the highest object this obstruction will be able to hide is still just 3 feet. So there's no way on a flat Earth that this will work. Whereas on a spherical Earth, the boat would start to dip behind the horizon. And then guess what? A 3-foot obstruction will be able to hide a 20-foot boat. I think we can end it here. We can put David on the list of flat earthers who can't do experiments, along with Bob and Jeranism. If you enjoyed this video, hit the like and subscribe button. I'm Heinrich, the real nuclear physicist, and I'll see you next time.